Assalamu alaikum wa rahmatullah. It's Mr. Fahad. Today we will continue with the 7th lesson, derivatives of exponential and logarithmic functions. By the end of this lesson, you should be able to find the derivatives of exponential functions and find derivatives of natural logarithmic functions. Okay, so let's get this out of the way. Here's the rules you need to derive logarithmic and exponential function. So a power x, if the variable is a power or exponent, then the derivative will be a power x, so it's the same as the expression times ln of a. And a is the base of the exponential term. Now, the other theorem here says e power x, the derivative will stay e power x. And last, the derivative for ln of x is 1 over x. So 1 here is the derivative of x. So derivative of what's inside over what's inside the ln. So in general, if you have a number raised to a function involving x, then it will be the same exponential term times ln of the base times the derivative of the exponent, which is f prime. And here also, in general, if this is not just x, an exponent involving x, then the derivative will be the same term times the derivative of the exponent. And last, you can see here, ln of f of x, the derivative will be derivative of what's inside the ln over the term inside the ln. That's all. So you need to memorize these in order to solve the questions. Here's an example. Find the derivative of the function t plus 2 power t. So in this question, we need to derive the first term and then derive the second term. Derivative of t, of course, is 1. And the derivative for 2 power t, according to the rule, 2 power t times ln of the base, right? Now in the second question, you got x power 3 e power x. And here we have to use the product rule. The derivative for the first term times the second plus the first derivative of the second. And the derivative for x power 3 is 3x squared. The derivative for e power x is e power x. Again, according to the rules in the previous slide. So now let's just simplify it. Take e power x as a common factor and take x squared also as a common factor. You'll be left with 3 plus x. And that's all. Moving to more examples. You can pause the video, try to do it on your own. All right, so with the first one, we have 3e power x squared. Just take 3 outside, find the derivative for this expression according to the rule here. So this will be 3e power x squared, same term according to the rule, times the derivative of the exponent. In this case, will be 2x. Now let's just simplify it, and this will be the final answer. So in this question, we will use the chain rule according to this formula, and this will be the same expression, a power f of x, times ln of a. In this case, it will be 3 times the derivative of the exponent. So 2 times 2 is 4x, and we can simplify it like so. All right.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, click the link in the description below and send us a message now. Okay, with that said, let's get back to our lesson.
Moving to new pair of questions. Pause the video, try to do it on your own, and then come back to check your answers. Okay, with the first one, as we did before, we have e to f of x. So this will be the same term times the derivative of the power, which is 4. And we can simplify it to be 8 times the exponential. The second one here, just use the formula. So you have a number raised to f of x, same term, times len of the base times the derivative of the exponent. And this can be simplified like so. Okay, more questions? Pause the video, try to do it on your own, and then come back to check your answers. All right, we need to use the product rule. So in here, the derivative of the first times the second plus the first derivative of the second. Derivative of x is 1. Derivative of len of x is 1 over x. All right, now simplify and you'll get the final answer like so. For the second question, we have len of f of x, and according to the property of logarithms, we can just take the power, multiply it with the len. All right, so this will be 3 len of x, and we know that the derivative for len of x is 1 over x, and this will be our final answer. All right, 2 more questions on the len. Pause the video, try to do one of these, and then come back to check your answer. Okay, so for the first one, we need to use the formula derivative of what's inside the len. In this case, it will be 3t squared plus 3 over the term inside the len. Similarly here, we will do the derivative for the cosine over the cosine of x. So derivative of cosine is negative sine of x, and this can be simplified to negative tan of x. So be careful when choosing the multiple choice for such questions. All right, one last question here. So find the derivative of the function f of x, x power x, for x larger than 0. So in this case, it's not an exponential function because the base is not a constant, and also it's not a power function because the power here is not a constant. It's both variables. So to evaluate the derivative of f of x, we need to take the len for both sides in order to get x down using the power property. So using the property of logarithm, I can take the power, multiply it with len of x, and the derivative for len of f of x, we need to derive both sides, is the derivative of what's inside over the exact term inside the len. So f prime of x over f of x equals, now this is a product rule, so derivative of x is 1, len of x plus x, derivative of len of x is 1 over x. We solved one in the previous slide like so. Okay, so now I have on one side the derivative, which I need to evaluate over f of x, and on the other side I have, after simplifying, len of x plus 1. So in this case, I can multiply both sides by f of x and evaluate f of x, which is x power x, and this will be the derivative of f of x. So f prime of x equals this expression. That's it for today. Thank you for watching. Assalamu alaikum.